Okay, hi and welcome back to, let's call it part B of video 2. So I guess that's what happens when you film videos on spring break. They decide to test the fire alarms this week and we get a little interruption there. So hopefully you weren't trying to watch this video as you were falling asleep and it startled you and now you're up all night. But anyways, the example's still up on the board. As I was saying, so because we're using the function value at the left endpoint, we never had to end up using 20.2 for our lower limit. So now it's just a bunch of crunching numbers. So if you calculate all these numbers, you should get 34.7 feet is the lower limit of the distance that she traveled running at these half-second intervals. The distance for the upper interval, so now we're using the function value on the right endpoint of the interval. So from 0 to 0.5, we're going to be using 6.2 times a half. And then 10.8 times a half. And 14.9 times a half. 18.1 times a half, the change in the interval. 19.4 times a half. And then lastly, our last interval from 2.5 to 3 seconds, the function value in that interval, now we do include that 20.2 times the width of the interval, 1/2. So again, you crunch all these numbers, you should end up with 44.8 feet. So based on this information that we were given, these velocity at half-second intervals, we can determine that she ran between 34.7 and 44.8 feet. Somewhere within that range, or that interval, that range, is her actual distance traveled. So that's it. That's a really super quick video, obviously, our little interruption there, but that's what we're talking about areas, talking about distances, lower limits, upper limits, just is telling us which side of the, which endpoint of the interval we are using, and then we're multiplying it all out by the width of that interval, or in this case, the time, the half-second. So that's it. Come on back. We'll start getting into really the heart of this chapter, which is going to be 5.2.